Welcome to this hybrid event arranged by the IET's Anglian Coastal Local Network, which represents members in North Essex, Norfolk and Suffolk. And welcome to those of you in the local audience here at the Atrium and at the University of Suffolk. It's really great to be able to meet face to face at last. Welcome also to folks joining via Zoom from other parts of the UK and indeed globally. I'm Kevin Foster, I'm Chairman of the Anglian Coastal Local Network, and I'll be your host for this evening. I'm delighted to introduce our speaker, Tiago Martins Andrade. Tiago is a senior researcher at BT Applied Research based at Adastral Park, Martlesham Heath near Ipswich, where he specialises on immersive technologies. That's VR, AR and MR. Currently he is working on cyber security in BT, making the analyst's workflow more productive, intuitive and engaging. And this involves developing new ways to allow data visualization and 3D interaction. Tiago has a master's degree in software engineering at the University of Coimbra, Portugal. His thesis was on locomotion in virtual reality. So Tiago, over to you.
Thank you so much. Hope everyone is well and at home as well. And like Kevin said very well, thank you so much for introducing me. I'm a BT researcher, so my goal is to try to combine this kind of technology with cybersecurity and see how valuable it is if we actually deploy this kind of technologies into our businesses and into our teams and see how well that comes up. And there's a lot to think about when developing these kind of tools. There's a lot of history all around this, and I think it's very important for me to share that kind of knowledge and for new generations to actually pick this up, find it interesting, and start us as well working a little bit on this. So immersive technologies are a bit of a blur in between data and actually how we work. So this is what I'm going to try to show in this presentation. So I'm going to show you the brief history and evolution of virtual reality, how it came to be, and how it's being used. Then, of course, how it's going to be used and the different use cases that we are trying to create all around that. And then a little bit of what can we do in the future, all right? And hopefully that's going to be enough for us to generate kind of a discussion and questions on Zoom. So I will start with a very big question. When do you think virtual reality was first used? And I'm looking for dates and from the audience. If someone can give me a date on when it's actually started being used.
Flight simulators, First World War?
Almost, but before that, there's a date before that we can actually get into it. No? No tries? Oh. So there's a debate between 1938, which is actually the first thing that we can actually call virtual reality, which is the stereoscopic images. Two images, very similar, but with a very slight offset, and with the right distance between your eyes, you can start seeing 3D images. And I will talk about how they work in a little bit, but some discuss as well, or some think that the 19th century was the one that actually created the first virtual reality environments, where people trying to paint panoramic views. So we can kind of say, yes, this was the first attempt of creating this kind of environments, but the first well-registered and well-fabricated piece of tech that we can say it's a tech, it was the stereoscopic images that we can see here. And again, I'm going to talk about how we can create this kind of illusion, because it is an illusion that we are trying to create all around us and trying to immerse ourselves in this kind of images. After that, in the 1950s, I can't say the correct date of the creation of this, was Sensorama. And this was a filmmaker that decided, oh, I want my audience to actually experience everything that I do when doing a film. It's not just the image or the story, it's actually the feeling and the smell and the touch of something. So we created this kind of weird contraption, which is where people were seated on a chair, and they could have an image of 180 degrees. They could actually look around, and they could have sound, stereoscopic sound, so nothing will come just in one direction. They will come all around the user, and then you could actually feel things with your hands, feel some trembling on the chair, and smell. Very important. You could smell things that were appearing on those images. So that was the first virtual reality, entirely immersed scenario that we can think of. Of course, this was very expensive to do, very expensive to produce, and well, it stayed like that for kind of almost ever. So the second thing that appeared, it was in 1960s, the first virtual head-mounted display. So this is nothing more, nothing less than a screen into your eyes, or two screens in this case. And the special thing about this was you could be mounted in your head, that's why the name. And people start using this and thinking, oh, we can actually create something of this. They weren't sure how to use it, what for, but this was going to be the ground up of the devices of today. All right, so 1960s, it's already kind of a decade ago. Following, and as you said, was when simulations of flight simulations start picking up, and they saw, oh, this is actually great for us to create some kind of a immersive environment, a safe immersive environment for our pilots to be able to try to understand how to pilot an airplane and actually throw some very different edge use cases to them and see how can actually deal with stress. And that's when things start appearing. And in 1968, it's when the first VR AR head-mounted display appeared. So basically, this device there, in the first picture, could track the person in a room with that weird mechanical contraction. You can move around, and mechanically, you know exactly the position of the user. And with that information, you can actually change the virtual environment, and the person could think, oh, I'm walking in this virtual environment. So this was the first step of actually capturing all around you. Of course, nowadays, we use computer vision to be able to track where we are in the room, or even base stations to kind of predict where you are based on infrared lightning. But that are everything. It's prediction. It's an approximated position where you are, while this one was the first actually very accurate where you were in the physical and in the visual. All right. Then between these dates, I didn't show you here, but it was the Atari crash. And Atari was a game company, and they thought virtual reality could be very interesting for games. However, they start investing on it. They put a lot of brilliant minds into it, mainly Brenda Lauren. I'm going to talk about her in a brief moment. But meanwhile, after a bit, I think they just run for 1 year or 2 years, and then it starts the Atari crash, and the company went bankrupt. So nothing from that actually see the light of day, unfortunately. As that's why I didn't put it on the on the map here. However, Jaron, and before getting to the 1987, nothing was called virtual reality. That wasn't coined yet. And it was this guy, Jaron Lanier, who came along and kind of started saying virtual reality is the tech that we are trying to talk about. All of this that came before. And it was actually the one that actually created the first VR company. He started creating headsets and virtual reality headsets, and he pushed this technology a lot forward. And one of the things that he did, not about the environments or how they can actually build the application, but more about the haptics. How can a person feel something in this environment? So we created a lot of the first gloves, haptic gloves, that you can now see nowadays. The first haptic suit is also coming from this company. And it's something that people don't know. People think when they say, oh, there's an haptic glove, this is new. No. comes from this guy. He already think about that. He already thought about that, and he said, there's some value here. Of course, it wasn't very known, and it took a lot of time to actually build this company. I'm not sure if the company is still up and running, but his teachings actually are helping us to uncover how can we actually use this and start applying in the current technology that we have. Moving along, there are the era of arcade machines in 1991, and there were VR machines at the time. They were machines that people could put the headsets. They were kind of seated down, but with controls that could move in the virtual environment. And most impressively, they were connected to each other. So multiplayer gaming is already a reality on an arcade studio. However, they stayed on the arcade. When the arcade died, all this technology also died with it, unfortunately. And we didn't kind of continue. Nowadays, we are realizing, oh, multiplayer and remote collaboration is very useful. No, in 91, they were already doing something to try to push that forward. But, well, we need to sometimes take a step back to understand how can we step forward, right? Then the cave came along, and this is kind of a different VR approach. Instead of having a display in front of your eyes, we actually have our room all around us to actually show the images. So the cave, the new thing that it comes is a projection like the projection that we have here, and it's projecting all the walls with the virtual world. And we have just a special pair of glasses that polarize the images, and each eye is getting a different image at a certain time and gives you the perspective of depth on that. So you could actually walk on this environment and you'll see in 3D, thinking, oh, I'm actually there. Most importantly, those glasses also tracks you, so we know exactly where you are, and also move the virtual environment based on your location. So you can actually have a true parallax effect when looking into this environment. This kind of didn't go anywhere until filmmakers start using it. The most recent one is The Mandalorian. Don't know if you saw already on this Disney Plus, but Mandalorian uses exactly this kind of tech nowadays to be able to create the final pixel environment they need just to shoot. And this kind of removes the post-production of a movie entirely. They all do everything in pre-production. They put on a very big cave machine. They render all the scenes, they shoot it, and that's it. In the end, you already have your final results. You don't need post-production anymore. So this is how we can actually leverage the very old technology, cave, into nowadays technology. Then the 93 came, and 95. What was the decay of virtual reality, unfortunately? So at this moment, some companies like Sega and Nintendo tried to push into consumer version VR headsets. However, they weren't very successful. Problem with that was image quality. It wasn't there yet. The computational power wasn't there yet for them to actually produce something wow factor. People want to buy this, people want to use this. And they were very costly as well. So they kind of lose track. They try to push it. Even they start dropping prices like crazy to see people, okay, now with this lower price I will buy it, but it didn't get there. And production-wise, they kind of dropped it and say, this is that. And for a while, we stopped having virtual reality altogether and kind of forgot it. Who didn't forget it was sci-fi movies, who actually saw a potential here to create new stories. Multiverse is something that now is a buzzword nowadays, came from a sci-fi novel from Neil Stephen. I don't know the name, from Snow Crash. So that's a novel that coined the metaverse, and now it's being used nowadays like crazy, and that's the new buzzword. But things like Ghost in the Shell, The Matrix, films like that start saying, oh, there's a potential here for us to actually show this. And nowadays we think, or looking back, we are driving our inspiration based on these movies. We are trying to actually replicate what these guys thought about. How could the future look like? And we are now bringing those knowledge, bringing those kind of crazy ideas and thinking, maybe it's not crazy at all. And we can actually do it right away. Something that it's people come to me to ask me is Minority Report, a movie that Tom Cruise goes in a very wide screen and he has special gloves and he can move data all around. People say, can we do this? Oh, we can start doing it right away with this kind of technology. And finally, to stop the evolution, because now we can go on and on on this, we arrived to the final destination, where is in 2012, a guy called Palmer Luckey thought, oh, this ancient technology, maybe it's time to bring it back. And he developed the Oculus Rift DK1. Everyone thought he was crazy, and he pushed it on, and he developed the Rift DK2, the development kit 2. This is the one that I got first of all. When I saw it, I must buy it, and I need to try it. And when I actually start seeing some experiences in VR, some usability of it, I thought, there's something here, and we should actually bring this into our environments, and what kind of value this technology can bring to us. And from this point on, it's when everything kicked off. So nowadays we arrive at the final destination, and there's a lot of VR devices. I just put 3, but there's a lot. I couldn't just show everything that is now on the market currently. There is big companies like HEC trying to do things, Google, Facebook, now called Meta, that acquired Oculus, and they are now pushing devices and trying to sell the metaverse as the new environment or new tool that we need to use in our company. So this is where we are at now, all right? So why now? Why this is trending, and why does this work? So I'm going to try to show you the behind the scenes a little bit. I'm not going to very in depth, but just for you to have a glimpse on why this works and why maybe this is going to actually change the way we utilize computers altogether. All right, and I'm going to try to sell that to you, and then I will show you how we are going to use it. So going back to the stereoscopic images, why this work for us? First of all, because we take the human adventures and we think, oh, we need to use this for humans to use, right? And this is the first thing. VR is not for animals or nothing. It's just for us to use. It's a technology just based on us and for us to use it for our own gain and have access, different way of access to data, all right? And it uses, of course, 2 images. Why? Because we have 2 eyes in our face. And those eyes are just our sensors to see the world. And they are actually capturing the same image, but just slightly off. This is enough for us to grab the depth perception. Most animals, they have side eyes, for example, but what they want to achieve is to try to cover as much area as they can. We actually want that perception. So that's why it's so important for us, and that's why we see things in 3D. So without that, those true images very slightly offset, we will not get any kind of 3D data for ourselves. Most importantly, they also need to be syncing. So we can't have 2 images just going around like crazy. They need to be both synced and just showing exactly the same thing. And they need to show us the perfect parallax between the environment that we are seeing and where our position in the world. So with that, we can actually see in 3D, and that's why that is so powerful, all right? Another thing that we can show is embodiment, all right? So there are 3 things that we want to achieve with this, which is embodiment, a presence or feeling that our body is in virtual reality, even if we are in the real environment. And presence. So we want everything to be around us to actually act on us if you do something. All right, that's very important. If we react to something and nothing happens, then we are not there. Then we kind of disassociate ourselves from the virtual environment. So it's very important to also have presence in these environments and immersion. So all the sensors that we have, like vision, hearing, taste, smell, start telling us the story that, oh, we are actually in a real environment. And with all of that, it creates the immersion, and all of that actually creates a way for us to think we are actually on that new environment that we are building. All right. And how can we actually differentiate this? So VR, it's not alone on this world. It's not just VR. There's a lot of other technologies in between. And we normally call it extended reality or XR. So we try to encapsulate all of that tech into just one word, which is extended reality. And all technology comes from reality until completely virtual. Okay, so we have the real life, that's we are now at the moment, hopefully. Then we have augmented reality, which is just everything stays the same. We just want to augment information on top of reality. For example, if we look into this share, it will tell me the price of this share. All right. Or if I look into my cell phone, instead of actually going to my cell phone, looking to messages, now it starts playing all the messages my phone has. That's augmented reality. But it needs the reality context to work. Without that, it doesn't work. Mixed reality, it's just a mixed ground. It's very gray area. We don't know where it is. It kind of shifts. Microsoft, who is one of the big pioneers of this mixed reality, doesn't actually tell us how to use it as well. So basically what they are trying to do is you can shift between augmented reality and virtual reality. And this is the gray area. So you can be a bit more in context of reality. So you'll have augmented information all around you, or you discard all of that and you have completely virtual reality. So it depends. And then, of course, virtual reality doesn't care about reality altogether. Your environment is completely visual. Your data that you're looking is completely virtual, and you just manipulate that kind of data. So why VR is so unique? Why I think this is actually going to change the way that we interact with data mostly. All right. Imagine that computers are theaters. All right. And this is not my theory. This is Brenda Lauren, which is the one of the pioneers of VR in Atari times before the big crash. So she explains, let's think about computers as theaters. What do you have? A big scenario. Actors will act on it, and you're just in the audience looking, things happening, right? And this is how you interact with the computer. You have your keyboard, you have your mouse, and you have your screen. You're not there. You are outside, and you're looking into a window of something happening, and you sometimes even type some commands that can happen on the theater as well. You can say something to the actors, hey, do this, hey, do that, and they will do it, but it's not you. It's them doing it. And you'll see the outcome. This is the computers nowadays. What VR is trying to do is actually changing the way that you interact with the theater. So if you put now yourself on the stage, and actors start interacting with you, and you do stuff, and they will react to the stuff you do, now you are kind of a new ground. You affect the story. You affect the way that you interact with the story. You affect everything all around you. And that's why we are trying to achieve with virtual reality. So if that happens, you think, oh, now I am the center of all things that are happening around me. Everything that's virtual can be interactable. And if I do something, there are changes that will happen, and I will be able to perceive those changes. And that's why I believe VR can be actually very useful on the future and years to come. All right. Now I'm going to talk about a little bit the techniques that we can use to make this a reality. I'm not saying these are all solved, not even closely. All right. Virtual reality needs something that, if you are looking about interaction fidelity, so basically how we interact with the world, we want something natural, but we are not there yet. We are still on natural, basically keyboard and mouse. So we need to start shifting very slowly, but hopefully shifting to natural movements. How can we actually use our hands? How can we actually use our body and feet to be able to interact with the virtual environment all around us, and not just the virtual environment, the data with us? That's very important. How can we grab data and see data and tear it apart and see how useful the data is to us in more a 3D way? So this is how this can start creating something unique for us. Another thing that we need to be aware is affordance theory. I learned this the hard way in my uni times. So I was studying like Kevin said, locomotion for virtual environments and trying to study how that affects motion sickness, how people feel motion sickness on these environments. And I wasn't aware that affordance theory was very important in this case. While people were doing the trials, I would say, oh, you can switch between different ways that you can move in VR. You can go to natural, you can go to more unnatural, and I will study the different motion sickness they will feel, but people need to do that. People need to change it. And I said, oh, press that button. And people will go into the environment and look around and say, what button? I can't see anything. And that's the problem. That was affordance theory. What I did was a box, a red box. And people will look into the red box and say, that's a box, that's not a button. Where is my button? So they were looking for the button. And that's what makes VR kind of unique as well. We need to be careful when designing this kind of environments. And we can't just say, oh, abstract data, there we go, see it. People will look at it and will not understand what they're looking at. So we need to understand how can we make 3D information actually valuable for users. Just for you to kind of understand a bit more, I'm showing this. What is this? This is just a graph, right? You have nodes and they are connected to something, but does this actually tell us what they are trying to show? No. If I don't label them, if I don't say exactly what is this kind of information, you don't understand. But if I put the correct 3D images to it, you will understand. Now you know what it is. Out of the gate, without any kind of information, any kind of tutorials, you know, oh, I see routers, I see computers, I see switchers. It's a network that I'm talking about. And how they actually connect to each other. And just the 3D information can actually give you more value than the 2D. Even though the 2D is great. I'm not saying it's not. They actually give us a lot of information, but maybe we can achieve better. Maybe we can create environments that actually utilize correctly the data and show you the correct way to use that data. How to solve it? I'm not sure. So other things that are challenges that we need to think about when creating these environments. Locomotion, it's another problem. We are in the physical world, we are trying to interact with the virtual world. How can we actually move on this new world? We have just a very restrictive area that we can actually walk. How can we walk in VR? So that's something that we need to figure out. When we try to do fake movements, so someone, okay, I'm gonna press a button and move, that's a natural movement from interaction. And that causes motion sickness. So we have to be careful how to do that. We can do something more less natural, and probably one step in reality is 7 steps in VR. We can start doing that. So we have to play. We have to play and see how it actually works. How can we actually move in this environment? If my steps or movements of the hands need to be one-to-one, or can we change that, fake that? and use that in our advantage. Another problem is input challenge. How can we actually write things down? We are too used to commands, too used to keyboards, too used to mouse. And we think we need, again, to tell, hey, computer, do this. Hey, computer, do that. But now with VR, you are the center of all the information, all the data. So how can you, with natural movements, tell the data what to do? So that's a big challenge that we need to face. And of course, user interface. How can we actually see that? It's not longer just display. It's all the information is all around you. You just move around, you'll be able to see the data. How can we actually interact with that? And the biggest of them all, motion sickness. It's the big bad. People still think, oh wow, the current devices still create this. Not at all. The devices nowadays shouldn't create motion sickness. It's the application that creates motion sickness. So it's the way you design the application is creating now the motion sickness. Because the devices already have very high frame rates, more than you should need, basically. The resolution, people can argue, is still not there, but one more or two more iterations, we are there. You don't notice any difference if we compress more resolution into the screen. You already see what you need to see. Now, what's causing motion sickness is how you actually create the applications. How do you move, how do you interact, and how you perceive your actions. And that's enough. If you think, oh, I can move the chair, and in VR, and if you try to move and it doesn't move, that's going to be problematic. That will cause motion sickness. That will cause you to feel that's not real, and I should get out. And this is motion sickness is your brain saying, get out. This is not actually what I want to see. And of course, we need to be very careful when developing VR applications, because it takes at least 90 frames per second, means 11 milliseconds for each frame to be drawn and thrown into your eyes. You have to draw two for each eye with slightly differences. So you need to have this in your mind. But of course, the computing power is becoming better and better. This stops to be, at some point, our focus. We need to actually, in my goal is we need to stop caring about all of this, because we're getting there. We just need to think, how can we actually make applications that work for us? And finally, we are going to use it. All right. There's already currently some applications on the market. Others are just research. I'm going to very briefly show you all of this and then show you what I'm actually working on. So things like Metaverse is trying to visualize your desk, basically. Removing the screen, removing the computer. You don't need that anymore. Just put the headset on and you'll be able to visualize everything that you need to see. All the screens will be virtual. You can open as many as you want with all information that you want, and that's it. So this is something that is already in use. Another thing is remote collaboration. So how can we connect to teams that are across the world? How can we work with people that they are not currently in my country? And virtual reality can help on that. Can create a true remote collaboration space where people can just do the headsets, they will see each other, they will talk with each other, and right away start working on whatever project they're trying to run on this environment. Another thing, of course, that video I think is very powerful. It shows you how can you create 3D abstract data into actually something that is plausible, and there's something that you can learn from it. So show an engine how it works. Can you change the variables of that engine? Can you remove pieces of that engine? It will still work or not. So we can start creating different kind of simulations, throw things at it and see if they work or not. And that, I think that's powerful. It's just no longer just numbers and saying, yeah, that worked. No, it doesn't work. No, you actually see something working or not. And that gives you more information to work with. VR rooms, this has been now the trend. Metaverse is trying, or Facebook is trying to push this very, very hard. So basically, it's the same, remote collaboration, and people connecting to the same environment and be able to quickly have a conversation, share some very easy information, and be able to actually see each other, even if you are working from home, even if you're just watching an avatar. That's enough for you to stop thinking, I'm alone. No, I'm actually with someone. You can actually see that someone, you can actually talk with someone, and that unlocks the idea of you're no longer alone working from home. You're actually working with a lot of people. Digital twins, there's something that also the industry is trying to invest heavily. So basically it's creating a virtual space of the real space, and that data will always be on. You can see anything. Normally they are connecting this to the IoT and driving all the data that we can do and build a virtual city, basically, or smart city, based on that data, and both coexist. So if something changes on the virtual, you'll see that effect on the digital, and the other way around. So if someone goes and changes the data on the digital, you'll see those changes on the physical. And that can be very, very powerful if well used, of course. And virtual desktops. So basically, again, it's the same. Those two videos are basically the same. More things that we are using, of course, it starts with entertainment, games, and people to be able to play together and have a new way to try new environments. Retail shopping, something that's now kicking on. You can try stuff without actually being on the store. You can start looking how it looks like, what is the size of it, by just pulling your phone and look at it, say, oh, this is the size, oh, this is the sofa that I want to buy. I don't like it. Let me change very quickly. This is a way that you can shop online, but still have the knowledge of seeing the object in real life and how it looks when trying to purchase something. Manufacturing, so this is something to pre-production again. So someone can simulate a build of a new car, new designs, and see how they work, everything in visual before actually kicking on the manufacturing phase and start producing like crazy. And then in the end, you say, I forgot something. No, with this, we can actually avoid those and before time know what kind of challenges we have. Healthcare, this is dealing with remote again, the remote doctor. So you can now have an operation and your doctor can be in a different country and using VR to be able to do your operation. That's a now possibility, connecting with 5G and very high speed ways to transport information. Now we can have VR environments that can help doctors reach very fast their clients, fix the issue, fix what they need to be fixed, and in the matter of very long distance, basically. Using historical reconstruction. So again, we can't see how the past was, but with VR we can. We can rebuild everything without any kind of cost and rebuild all of that based on information that we have previously. And people can put the headset, explore that, see how it looks like, actually go inside, try to find new things with VR. And training, we can start having very powerful training for people. So instead of trying to simulate or role-playing with others, now we can actually create some different and very difficult and very dangerous scenarios in a safe environment. Doesn't affect the real at all. They can actually experience that very difficult situation and they can learn from that. So I'm going to show you actually what I meant with that, because I built that. And this is what PT is doing. There's a lot of projects. I'm not the only one working on this. My colleagues are also looking into this, mainly the digital twins. How can we have these two digital worlds working together? Connect ambulance. How can BT offer the right infrastructures for us to share that kind of information very quickly, mainly 5G, 6G, or whatever it comes next? How can we integrate these technologies and make this connect very quickly without any kind of pre-installation or trying to build a structure? No, we can already have that. broadcasting more information on sports. Someone is seeing sports, we can use AR to display more information, all right, on the go and live. And then we achieve, of course, my trainings, which is actually trying to visualize everything we want to do and create better training for people. So we achieve, or we arrive on my projects, and I'm very proud of them. And one of them is to try to look into how cybersecurity works, how the space they utilize, why they utilize those physical spaces, why they need that, and what they do with them. So basically, what I've understood, they go to these very high secured facilities, and they are trying to get access to data that you can't just access. They need special permissions to access. And with that, they can actually collaborate with their teams to try to find malicious software propagation, DDoS attacks, anything that is harmless to the network or to the infrastructure. We need to predict those very quickly, and we need to shut them down before they actually do some damage. The question is, why do we need the physical space? And COVID actually showed us, maybe you can't go to those physical space. You are forced to work from home with just one screen. And you have billions and gazillions of transactions going through all over you. How can you deal with that? And this is where VR can come in. So that's me. And this is a demo that we actually have in our applied research department. And as you can see, this is a virtual environment that we can be customizable. You can make it your own personal VR space, and then you can open as many screens as you want with all the tools that you need. In this case is BT Nexus and BT Saturn, so two BT security tools for you to see your own network, and you can create as many as you want. And then, because it's 3D, you're not tied to the monitor anymore, you're not tied to a computer anymore, you can actually grab them, scale them, and make them smaller, make them bigger, put on the wall, put behind you, whatever you need to actually understand what kind of data you're dealing with. And another example is connecting with your colleagues. So right now, I'm connecting with my colleague, which is in a different part of the company, and we can see each other. I'm talking with them. I'm sorry we can't hear it because I didn't put any sounds, but we are talking. I'm requesting, hey, please give me that screen over there. He can grab, he passes me, I can grab it in real time, move it to a wall, move whatever I need to do. And this can be even for training. So one can be the trainer, the other the trainee, and I'm teaching him how to use the tools in real time without actually being with them. This is how powerful we can make things. Another thing is teach. So now I think I'm going to more in the realm of teaching people and training people. And how can we teach our network operation centers or our security centers how a data center looks like without actually taking them there? Because it, again, requires special requests to be able to go to the physical space. You need to disconnect routers from the network for them to actually see them, play with them, see all around, connect them. Probably you can't do that. So this way, you can actually have a virtual data center. You can look how the router looks like. You can have special information about that router when you grab it. And there's actually a narrator on the background explaining what to do even. And you can remove each card, see how they look like, try to build your own and see if you can actually make that a possibility. And with that, you have better knowledge how to build one. And then if you're trying to convey with a field agent that is doing a repair, you know exactly what to say to him to be able to do that repair. And finally, how can we make physical risk awareness for any kind of stuff that works in BT? So one thing that we have a lot of new joiners. We have people that never saw new buildings. We are trying to create a new workplace, like the Snow Hill building in London and new places in Birmingham. And we are trying to create new dynamic space for people to come and work, but they never saw how they look like. They never saw what kind of restrictions those buildings have. So with this, I can replicate any kind of BT office. They can explore freely how the office looks like and go around. And meanwhile, they need to be security aware. So they need to find if there's any documents lying around that people didn't intend to, and they are very confidential. If there are passwords written on the monitors, should I report it or should I ignore that? If there are people without ID cards on security floors, should I challenge them or should I ignore them? So things like that. And the system is scoring them on behavior. So they are trying to understand what people are doing, trying to score them, and then in the end says, hey, this is how well you did security-wise. If you were capable of actually spot everything, or if you just want nuts and report everything, and that's also not very useful, or if you missed things, so you thought, oh, there was a secure risk, and you think, no, that's just fine, there's nothing. So how can we actually move your focus and say, no, why are you just ignored? It's actually very important for you to look at. And this is one way to do it. So in conclusion, hopefully I give you a lot to think about. Again, this is just research work. This is just for us to think about how can we grab these kind of technologies and apply to our day-to-day work. And what I want to left you is think about remote collaboration. That's going to be something unique that we can use VR for. We don't need to be in a physical space anymore. We can have a virtual space, and anyone can actually attend that virtual space without moving from home or from their own office very close to them. So you don't need to commute anymore. How can we make this a possibility for people? We have access to information and virtual information. So how can we make that useful for people to start understanding and manipulating that information to their own gain, to their own organizations, and how can actually manipulate the information that gives you the more information to yourself. And of course, how can we use hands? That's still a challenge, a very good and tricky challenge that we need to solve. How can we use our natural language, because it's a language that we use to communicate with ourselves? How can we translate that to VR and use that to interact with the data that's all around us now? Thank you so much.
Thank you very much, Tiago.
Yeah,
Thank you. Absolutely fascinating insight into your world of research at BT.
yes.
And I just wish it was as easy as you've shown it to do the 7750 SR12
Yes.
router.
Yes.
Having put a couple of those in myself, I know they're very interesting beasts.
They are.
The training aspects of being able to play around with that in a virtual world before you go and do any physical changes, very powerful.
It is.
So thank you very much. I'd like to hand over to my colleague Ian, who's going to handle the Q&A. Ian, are you there?
Yeah, can you hear me, Kevin?
Yes, we can hear you in the atrium, loud and clear.
Okay, that's good. So we've got 4 questions at the moment, or 6 actually open questions at the moment. We'll start with one, I think, which is exactly the kind of question that came up for me, really, is how advanced is data visualization gamification of security, being able to wander around with the data and spot anomalies? And I know, Tiago, you covered a little bit of that in the presentation, but that came from Ian Beveridge.
So I think I understood correctly. It's how well are we currently to be able to do that? I'm correct?
Yep.
So I think we are still a bit far off. All the work that we have is still research work. We don't have at the top of my mind, I don't see any current application in production that utilize this, but it's something that we are looking for and try to understand how can we actually make this useful for people. So in my view is we need to to kind of research more about how can we make 3D visualizations more useful or more interesting for us to see, even if it's in a normal computer. If we can start doing that in a normal computer, then we can very easily translate that to VR. So it's how can we grab data and analyze it in a way that we can create then the 3D representation, or the correct 3D representation connected to that data. I'm not sure if we are there yet, but with time, I think we'll get it correctly. So it's about thinking how can we utilize data, how that data relates to us, and because of that relation, how can we represent that relation to the data. Hopefully.
Okay. Thanks, Tiago. We have another question, I think, that someone sent in here who obviously plays games, because it's from an S Knight, and it says, has VR mastered real-time movement simulation? This, in my opinion, was a flaw with Nintendo. I don't know whether that's something that you would know about, Tiago, but could you try and answer that one?
Sorry, can you repeat that?
Yes, it's has VR mastered real-time movement simulation? This, in my opinion, was a flaw with Nintendo. I don't know what the flaw was.
Yes, so again, we are getting there. I believe now the current devices can actually have a very good motion tracking devices that can actually relate all your movements in one go. If we are talking about, for example, remote controllers and Oculus or HTC Vive, they have the motion control, they call it the motion controllers. They actually track your hand movements very correctly, but it only tracks your hands. That's the issue. We are having a very overload of sensors that are trying to collect a lot of information, but we are not targeting the right things. So if we want to move, then we stop having your feet tracking, for example. So what we do to try to accommodate that is your head position. So if you're moving your feet, you're moving your head, so we track your movement by the head. But is that enough? Do we need actually to track your feet? Imagine that you're trying to do something with your feet, then it's not being tracked, right? If you're trying to step on something, that's not being tracked. So it's a matter of finding what we want to track in virtual reality and how can we achieve that without overloading the system, because trying to monitor everything is going to be impossible as well. It's going to be an overload of information, a lot of data, and we can't handle that. Just to finish, I think the current devices do a very good job to try to predict, like I said before, and they try to do predictions based on your previous behavior or what you're trying to achieve. But I think we need a bit of more work to make that seamless. So to make that you do something and the application knows exactly what you're going to do and show you that movement very correctly.
Okay, thanks, Tiago. Before I just come back to the audience, Kevin, there's just a couple of questions that perhaps Tiago can answer, and then we'll go to the audience. But the first, they're kind of related. The first is, as we move to from physical desktops to virtual desktops, how much power is that all going to take, and is that going to cause more environmental damage?
That's a good question. Hopefully, it will reduce it. Hopefully, that's what I'm trying to achieve. I'm aware that Microsoft is trying to do already something like that. So we start having windows or virtualized windows. So you can have they are utilizing Azure, for example, services to be able to open your own windows very quickly on any kind of device. So you have one machine running on the background on the edge computing or even in the cloud with all your information. And with that, I would assume it will reduce the cost, because now you don't have to have every machine with every account that you logged in trying to connect and install everything that you need. No, everything is centralized. Everything is going to be in one place, and it's only going to stream that data to you when you need it. And Microsoft is trying to do that. So Microsoft is trying to give you Windows on the go. So you just grab your phone and I need this, and it will go to the server and say, hey, this is what you need. If we are able to achieve that, that will reduce a little bit the power consumption or the impact, the environmental impact that you're creating. I can't say for sure because I never tried myself to measure these values. So it's something that we need to research upon and see how is the costs of having for something, for example, a cloud service running in the background with all the information against something that you have locally and you need to do it over and over again if you want to change device. So this is, again, I think that's a very good question, and it's a very good research topic that we need to engage and see how can we improve that.
So thanks for that, Tiago. And probably a related research project, Dara asks whether there's been any studies on the effects of long-term virtual reality headset usage, such as those on the vision of users.
Yes, there isn't been a lot of studies on that. I can't say by heart, but there are a lot. And you were mentioning the probably vision damage or fatigue. However, there are actually research that actually fix your eyes. So there are people trying to use VR and the lights that the screens emit to your eyes, and use that to, for example, fix lazy eye. Just by differentiating the contrast between eyes and giving more incidence for the eye that needs to be corrected. And there's an evidence that we are actually, they are helping people to fix that kind of issue. So it's a double sword, that question, because you can see a lot of studies saying it's going to be bad for you, and you're going to be seeing a lot of studies that say it's going to be beneficial to you. I think the problem here is the context behind it. What are we trying to achieve with this technology? Is it for everyone? I don't think so. So we need to be seeing this case by case and person by person, how it affects it, and how can we actually build a system that works for everyone. And that's very tough, very difficult, but I think it's possible. So it's just for us to keep on what we are doing and try to come up with the right narrative and come up with the right technology to be able to then have something for everyone to use.
Okay, thanks, Tiago. Is there a question that we could take from the audience, Kevin?
Is there a question from the audience? Let's start with Gavin.
Hi, sir. Great talk. I've got an Oculus 2. We've just started using it for meetings at work, collaboration with people from different countries.
Yep.
But I wouldn't want to wear it all day, and it's quite bulky. Is the key to reducing weight, do you think, offloading processing into the cloud or edge compute? Is that the secret? And therefore network latency really needs to come?
Yes. If we imagine a perfect world, we don't have any kind of latency, that will be the right way to go. So everything is going to be on the cloud or in the edge computing at least. And you can your headset is going to be just a window to that. So it's a way that we actually redefine the internet or the way that we connect to the internet, and how can we actually see that? Of course, that's not possible yet, but it's something that I think the path is to in the future to take a big advantage is if we can actually offset everything somewhere else, not with you, then that kind of scenario starts to be useful. And more useful is you saying you get fatigued with VR, with a headset in your head. So if everything is on the cloud, you can just take it off and grab your monitor, and you should still share the same environment. So multiple devices with different approaches can still see exactly the same thing. And that's the powerful thing of the metaverse that we are trying to create. Is something that is persistent over the internet, and any device can kind of have a glimpse onto what you're trying to do. So for example, in a meeting room, you can have your headset, so you'll see avatars and people, and you start talking with them. You are fatigued with that, you remove your VR device, you grab your phone, for example, and you still can be seeing the environment, you can still see people on that virtual space, you can still communicate, or go to a desktop, and it becomes kind of a game. So it's just in one window, and you control that window where you want to be positioned in the virtual space, but you still see the people, and you can still communicate with them. So it's a matter of finding the best balance, try to offset everything to the cloud, and our devices are just windows to that and not have anything localized to us.
Okay. Thank you. Thanks very much. Now, Felix, I think you had a question.
Yeah, thank you, Tiago, for your wonderful presentation. Looking at one of the applications of beyond 5G, tactile internet technology, which uses sense of touch. How does this relate with VR? I'm sorry.
Yeah, that's a good question. It's a tough one.
Tiago, just for the benefit of people on Zoom, could you repeat the question? So, because I found it difficult to hear.
Sorry. So, what's your name?
Felix.
Felix. So Felix asked if 5G technologies.
Yeah, beyond 5G technology.
Or beyond 5G technology, how can we use it?
Tactile internet technology using sense of touch for shopping and all the stuff. So you can be at the comfort of your room. You can try out, clothes, shoes, and everything. So what's the relationship between VR and this technology?
Could you understand now?
I think so.
Did that come over, Ian? Did that come over okay?
Yeah, I think we got it. Yeah.
All right, great. So, like I was saying, it's a window, right? There's already Shopify. There's already a lot of tools that allow you to visualize things on shops or in the internet. And VR is already, that kind of technology already exists. So some companies already start using VR to show you your future house, for example. How can you decorate your future house? How can you actually put sofas around? Or how can you go to a shop, online shop, see the objects, buy it, and you have it at your doorstep? I think the question there is, how can we connect all of that?
Yeah.
And I think that's a bigger question.
Yeah,
so
relating the air gear stuff. Yeah.
So it's more about how we utilize and the internet at the moment, right? The internet at the moment is built in a way that you don't want to see the data. You just do transactions and it will take care of that. What VR is doing is differently. So it's grabbing the data and it wants to show you the data. So the internet needs to change in the way that the VR device will actually be able to do what you want to achieve. It's difficult to say how to do it. It's very theoretical. In my opinion, is again, we first need to change the way we do stuff. We can't have just transactions going to someplace abstract and we don't care about that. Because what VR is trying to do is grab that data and show you to you. It's trying to give you the real representation of that data. For that, we need to kind of change how we manipulate data over the internet and how can we actually correlate information over the internet. So it's very interesting when, for example, Meta or Facebook tries to relate your personal profile with other stuff you do. So that's why they're trying to very eagerly try to understand your behaviors, how that affects your shop way to do stuff. For example, oh, I saw that, I want to buy that. They're trying to create those connections. Those connections are actually more useful in VR, for example, than in the normal internet. So I think, first of all, we need to build that. So we need to find exactly what we're looking for, what makes us work with data. And when we find that relationship, it's when we start empowering these technologies to show that.
Okay, thank you very much. Just to be aware that the tactile virtual reality is something that is still in your research lab, but it's something that your group can start looking at.
Yeah, exactly. One good example for that is the health doctor remote thing. That's a very powerful use case.
But for now, we are having problem. The 5G, the data rates, I don't think we can achieve it. It's still within the lab yet, so it's still theoretical or still on experimental stage. So
but
that's why you have the beyond 5G
latency issue.
Yeah,
exactly.
Issue.
But that's an infrastructure problem. We need to fix that first.
Yeah.
We need to make things infrastructure ready to, and then we can pass all of that. Because VR, what we're looking at, it's the final vision. It's what we want to achieve. But if nothing in between is done yet, we'll have that kind of issues. So that's why he's saying 5G is not ready, and probably it's not.
Yeah.
Maybe it's many more iterations on that.
It's still something system still ongoing. So
Exactly.
that's why we have the beyond 5G. So every other technology, just like you have 3G and 4G, we have different, 3.5, 3.2, LTE and all the stuff, advanced LTE. So before
yeah, but we need to develop that first. And
Kevin, can I just interrupt? It's difficult to keep up with the conversation on Zoom for the colleagues that are on Zoom when it's a discussion going on between one in the audience and Tiago. So I think we should stick with the questions if we can, please.
Yes, sure. Okay.
Is there any more questions from the audience?
Yes, there are two more questions,
Okay.
and possibly one from me, depending on the time. Gentleman at the back,
Sorry,
please shout.
I was very late for your lecture, but I was very interested in the discussion. There's a lot of discussion in the industry around digital twins, and this obviously has some interaction. I don't know whether you covered that in the lecture, but I just wondered, there's a sort of a connection which I haven't seen. There's like a VR universe, there's a digital twin universe, but they're clearly interrelated. Yeah. And I wondered if you were aware of any research or activity in that area.
Yes, my colleagues are actually.
So hang on a moment. Yeah. Did that question come over, Ian?
Yes. Yeah.
Okay, great. Tiago, please.
So we are actually researching on that as BT. How can we actually create the infrastructure to be able to produce that? And it's very important, like you said, the connection of it. It's not a digital twin if we just grab the information, create a virtual world, and that's it. If both don't affect the other, or one doesn't affect the other, it's not a digital twin. So we need to create those bridges. We need to create those interfaces, the correct interfaces. And like I briefly said, that was if something happens in the physical world, that needs to be reflected on the digital, and the other way around. So if we are in the virtual, if we do something, it needs to kind of feedback to the real. One research project that we are working on, I'm not working on that. That's my colleague Ana Sol Peña Rios, which is leading that. She's creating for the field agents a digital twin of all the network of a building based on BIM files. So we have that information already at our disposal. It's just a matter how can we actually merge both. So what she's trying to do is using the mixed reality device. A field agent needs to do a repair on a cable. It jumps into a room where the cable should be. He looks into the walls and puts the the mixed reality headset on it, and it will overlay automatically where the cable is. And he can track it. He can go and try to find where is his origin, where is his endpoint, where is the malfunction part, and he can go there and just do minimal repairs to that cable, for example, to fix it. And this is a way that we can have both worlds. And if he does that repair, the virtual environment can already tell him if it fixes that problem or not. And that's a way that we can integrate both worlds, I think. Yeah.
Okay.
Hope that answered your question.
Thank you. Mark, I believe you had a question.
Yeah, thank you for the presentation. You said when you were talking, showing the example of the church, and you said it could be rebuilt at no cost. I challenge you on that because I believe the cost of building a virtual model of things at the moment is A, hard, B, time consuming, and C, costly.
Yeah.
So I'm wondering what sort of, are there a new generation of tools coming on or capabilities that are being used to create better virtual environments?
Yes, of course, I kind of dramatized that just for the sake of the presentation. Of course, at this moment, it costs a lot to be able to accurately build, for example, a monument from the ground up. You need to historians, for example, to make sure everything is being accurate, and you need to then 3D artists to be able to create the assets, someone to build it. Well, it takes, like you said, it takes a lot of time. However, I think we are reaching the point that, for example, game engines are doing all that heavy work in runtime even. So you stop having that pre-production or heavily someone invested on creating a very specific asset. Stop having that. Now you have a more hybrid approach to things, and the archaeologists can go and look into a site and say, these are the informations. And as you soon start plugging that kind of data, we can start from using, for example, Unreal Engine. That's the one engine that I use. We can, in real time, start pulling that data and say, oh, we can build this like this, and predicting how the building will look like, even without someone trying to go very in detail. So it saves time, just based on someone saying, oh, this is the coordinates, this is the kind of stone here, and right away the engine can start building that from the ground up. That can save a lot of time. It's not there yet. Unreal Engine 5, and now it starts introducing that kind of notions and concepts to the engine. And you can start having very detailed assets from the ground up on the Unreal Engine 5, out of the box, without any 3D artists on the background trying to design them. But it's something that is being built on. So I believe in a very near future, you can very effortlessly or very quickly have a VR environment that you just say, I need this, 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 and this, and it will build for you. Okay.
Thank you. Ian, are there any more questions on Zoom?
Well, I think because time is getting on, we'll probably just take a couple of what I hope are fairly simple ones, and then we might just have to go back to the audience where you are. But this one was a question that kind of confused me slightly as well. So Doug asks, what is the difference between MR and AR? They both seem to be a mix of real and virtual. Is there a quick answer, Tiago, to that?
I don't have one. That's a good question. Like I mentioned, it's a very blur road between mixed reality and augmented reality. I believe the big difference is how you interact with data. So augmented reality just cares about the real world, and normally it's accessible by a phone. So your interaction with that is very basic and non-interactive, basically. It's non-natural, sorry. So you're not doing natural movements to be able to manipulate the data. You're just throwing a camera at something, and that camera will recognize that object and return that object plus more information. That's what augmented reality is trying to do. Mixed reality, it's more about the interaction with that virtual object. All right, so you have a physical object, you have a digital object, and what mixed reality is trying to do is combine both into one view when you use HoloLens or something else, and then you use your natural movements to be able to interact with that virtual object. So I think that's the difference between augmented reality and mixed reality. I can be wrong on this, but that's my
Thank you.
that's my view.
Ian,
That's a good. We'll just take one more off my list, and then perhaps one more from the audience, Kevin, if that's all right. So,
view the time.
yeah, in
Right.
view of the time. So this will be the last one that I think we can do off here. David Bauer asks, I can understand simulating head movement and the use of haptic controls for hand movements, but how is forward and backward body motion handled? Suppose you wanted to walk through an art gallery. Again, Tiago, is there a relatively short, simple answer to that?
We can achieve that with, again, more sensors. So there is something that I'm aware of, for example, the HTC Vive offers, which is a track sensor, basically. Just one simple track that you can put on you or on your shoes or anything, even an object. And for example, like the example that you gave me for art gallery, you can have multiple sensor cameras trying to track those devices. So if you walk and you have one sensor with you on that, we can very quickly start predicting where you are and where you're going, and then manipulate the virtual environments based on that.
Okay, thank you. Kevin, is there any one last question from the audience in the university?
There is one from me very quickly. Building on Gavin's question about headsets. I mean, the headsets are very clunky and difficult to wear over a period of time. Can you say anything about the development of future headsets, particularly maybe active glasses or active contact lenses that give you a sort of virtual reality feel without the huge, great weight on the headset? Is there anything there?
I think there is. Facebook is trying to do something like that. So in partnership with Ray-Ban, for example, with their own, I don't know how they call it, but they're trying to create at least a mixed reality glasses that you don't need a clunky device over your head to be able to see the virtual or augmented or whatever they're trying to do. I don't think it actually does what they intend to do, but what they're trying to do. The device clunkiness is about how powerful a device needs to be locally. Again, I think it's the question of where you want things to be done for you. So if you're trying to do without connected to the internet, if you're trying to visualize a virtual space just with your hardware, you need something a bit big to be able to have that process capability on your side and to be able to generate those virtual worlds. But if we achieve the moment that everything can be offset somewhere else, then probably you don't need a clunkiness device. You just need something that opens that, connects to that, and starts streaming just to you. Just a very quick image, 2 images, sorry, for each eye, and that will be enough for you to interact with the virtual world. Yeah. So if you achieve that, you probably have just a pair of glasses.
For me, that will be the way that I start to use it, to be honest. Anyway, on that note, thank you very much, Tiago. Great talk. Lots of food for thought. Thank you, Ian, for arranging the questions or fielding the questions. And Tiago, thank you for taking the questions. I know we've overrun a little bit, but thank you. Just join me in thanking Tiago, please.